All right, we are recording now. Okay. All right. What I'm going to do is I'm going to share that summary, or maybe share the transcript, so we can quickly refer to sections if anybody's got questions. Do that. Share. Go back to share screen, and then I'll just share the. Get the. Okay, this is the summary. This is the full thing. Okay, so there are the sections in between. So we have gone up to. Our time starts at about 40 minutes into it. All right. You would like to fire away with a question or comment? Should I just give a general comment? I think they're trying to make a lot of the aspects too complex, but I think they also touch on a lot of things which aren't quite to do with time, which are very interesting, which I would want more details on. I don't know. What do you guys think?
Well, I did, if I may share my thoughts with you, that this idea of entropy at some point in time could turn if you had enough time and go the other way. And it sounds like something that is highly improbable, although possible. It's not something that one would accept as part of the greater order of things, so to speak. Entropy is entropy. It starts ordered and it goes to disorder. And that's what we kind of hang our hats on, or am I mistaken on that point?
Well, I don't know. Barbour says that it's pretty clear that the system moves from a low entropy to high entropy, from order to disorder. Obviously, you can have local spots where you apply energy to turn things in the other direction. That's how life exists on Earth. So, yeah, I think it's if energy is flowing from one, but on average over the whole universe, everything is flying apart. And I actually thought he made an interesting comment there, which I've got a comment about, something I've never thought about. He made the comment, the universe doesn't have any rotation as a whole. How does he know that? Maybe, in fact, this could be an explanation of why the universe is expanding all over. The whole universe could be spinning around. And this is another question. I don't understand their problem with Mach's statement, which is, to me, just patently wrong, that you need to have other things around. If you're spinning a bucket for the water to climb up the sides, there has to be stuff around with gravity. I don't believe that at all. I think it's very simple. If you just take the case of swinging a weight around on a string, that weight has a motion in a direction. It's simple Newtonian physics. It wants to continue that in a straight direction, but you're applying force with a string to hold it towards the center. And that's why it's going around in a circle and pulling outwards. It's pulling outwards because it wants to carry on going in a straight line. It's got nothing to do with any gravity of any things around it. If you were the only thing in the universe, if the universe had expanded to nothing and you were in space in a spacesuit, if you like, and you could see nothing, there was nothing else except yourself. If you felt your arms, your hands wanting to move away from your body, you can't see anything else around you to know that relative to those other things you are spinning around. But you would know that you're spinning around because your hands are being forced away from your body. You have to apply energy to pull them in. So you must be spinning around. So I don't understand the problem with that whole Mach's principle thing. It's just wrong. I don't understand why Einstein fell for it. I don't understand they're trying to make it more complex than it is. It's just, to me, it's just simple.
I
That's just
agree.
one of the problems I have with that whole thing. But there are other things I agree with, other things they say that I find very interesting. Pierre, have I got it wrong?
No.
Pierre, you still with us?
Yes, sir. Peter, go. John. no.
Go ahead, Pierre.
I think John wants to say something.
Yeah, no, it's all right. All I'm trying to get to is with this aspect of time is, have you ever thought about how they say it's the arrow of time always goes forward? If you can think about the past, if you can think about the accuracy of something in the past, is that not reversing time? Or your understanding of time? It has to be personal. What I'm trying to say is time is dependent on your interpretation of that instant. He started off saying it's right in the beginning, and he said that it's relative. That doesn't define, to me anyway. I still hang on, and I'm fascinated by things about time. I still can't get the personal angle of it, and time matters to you, because when you're doing your engineering and all your futuristic stuff, time is fixed onto one of the dimensions, X, Y, and Z. It's space. And the space expands, and that's with the time. Nothing else changes there. So it's made it very complicated by not, by introducing all different aspects. I can't see them myself. Anyway.
Can I comment, John, with Pierre before you? Well, Pierre, would you like to make your comment first?
No, carry on.
So what I like is what he mentioned. I didn't realize it was Mark that had said it. That time is just a construct in our minds to make a sense of the universe around and to sort of navigate our way through the universe. Everything is dynamic, and it's just our way of at our scale, on the human scale, being forced to navigate through it. And essentially, it's a construct where you're comparing a change in one thing relative to the change in something else. But those things that are changing don't know about time. They're just changing, and they're changing based on certain physical laws. Their speed, the momentum, the direction, the acceleration, the chemical change, whatever it is just based on certain things which you can break down and write formulas for. So where we pull time out of it is just our own construct to make sense of it. So saying that time can reverse, time is not an engine up there somewhere hidden in space that if one can find it, one can chuck it into reverse gear. It just isn't something like that. It's just an abstract construct in our minds. All right.
Yeah.
Brent done.
I was wondering if there's any relationship to time and memory, and whether the universe has a memory.
Interesting question. Why should the universe have a memory? Why would that be a thing?
Well, then you could explain time, couldn't you?
I don't quite follow what you're saying. Why would the universe having a memory explain time?
Well, only we have got a memory as a species. But even we fade and change into whatever other concept we might imagine.
Okay, to have a concept of time, you're right. We have to have a memory of past conditions of objects, past positions, past speeds, past things, and so that we can compare it with where it is, where we observe it to be in the present, and where we can predict where it's going to be. That's essential to being able to be alive. Almost, it's like something which is an essential part of evolution that we had to develop. Without a memory, we wouldn't be able to predict. If I have to I have to jump on that buck's back and cut its throat and then go and eat it, I have to predict where it's going to go. If I can't do that, then I'll die.
Yeah. Quite right.
I think the concept of the universe as a memory, I don't think is quite right. The universe does not evolve because of the memory it has of where it came from. It evolves because it's obeying the laws of physics. I think Julian Barbour, right at the beginning of the discussion, differentiated between instances in time and the interval between different instances is an interval. And if we think that we are quantifying or a construct of the mind, Derek, as you called it, we use atomic clocks. I was intrigued by the term that we need more than one because there are glitches in the atomic clocks. It's the atomic clocks obeying basic physical laws, which are very precise. And that is why we use that to measure the, let's call it intervals between different configurations, as you were, of the universe. I do think this discussion would be a bit more meaningful if we just listen to the 10 minutes of the arrow of time.
Yeah, all right.
That's quite important. Then I just want to add one more comment. All the laws of physics are invariant on the direction of time.
Right.
Just remember that statement. Roger Penrose had quite a lot to say about that when he developed his conformal mapping model of the universe, of the Big Bang.
Yeah. I think the mathematics works either way, but I don't know whether that means that it is so. It might be that to my mind, the mathematics is not complete, possibly. But one thing definitely, when you're touching on atomic clocks and so on and glitches, one thing they don't really touch on is the effect of gravity on time, so to speak, or on the way clocks measure time. So I think that's a very fascinating topic. So I think, yeah, some of those glitches in those atomic clocks could well be gravitational waves passing through the Earth and passing through them and sequentially as it goes through. And yeah, and
That's
even
right.
the moon. Remember that guy that Pierre Hugo had out to give us a demonstration? I don't know, he'd written some book and wanted to talk about the book he'd written, but he had bought 6 atomic clocks from California and he put them in 3 places around the peninsula and in Stellenbosch and in Betty's Bay, I think. And he measured for about a month the differences between 2 clocks in each a meter apart, in vertically a meter apart, within a safe, protecting them from all other gravitational influences and trucks driving past and stuff. And the 28-day graph, it showed a sine graph of the differences, aside from some glitches. Again, there was a difference of about 20 billionths of a second and I linked it to the phases of the moon. It was absolutely linked to the phase of the moon. If the moon was at the opposite end of the Earth or near the clocks, that would be the difference in their speed of time measuring. So that to me was fascinating. And what was also interesting was there was one time when all 3 clocks showed a jump and drop back down in their measurement of time. I think there's a difference of about 14 billionths of a second, which sounds like nothing, but that's the small effect that gravity has on time. But it is an effect, and they're all 3 at the different places in the Western Cape showed that same glitch to the same quantity at exactly the same moment in time and date. And that had happened to be, when I checked, it was 4 hours before the big earthquake in Christchurch. So I wondered whether that could have been an effect of a gravitational wave passing through all of them at the same time. And possibly that gravitational wave had an effect on triggering that earthquake. Anyway, that's an aside. But I think, the effect of gravity on time, that to me is a whole topic on its own and very, very interesting. And what is the explanation? That is a big question. What's the explanation?
Well,
I think it's all fascinating. Love it.
Sorry,
gravitational shift is well known, and that is the same as the effect of gravity on time. It's the same thing. It's the same animal.
Sorry, I didn't hear the first part, Pierre.
I say the gravitational redshift is a well-known phenomenon.
Yes.
That's the effect of gravity on the wavelength of photons.
Okay.
So that's the same as gravity's effect on time. That's one manifestation of it.
So if an atomic clock is oscillating components within an atom, isn't it? So that if that frequency changes by that fraction caused by gravity, then that could explain the change in its reading of time. Is what you're saying, I think.
Yes, partly, but a gravitational wave has got so little energy. I don't think it can affect an atomic clock.
All right. Maybe what that glitch was that we saw in those clocks at that time, maybe it was just the Earth giving a shudder then. When that earthquake was about to happen.
I'm impressed that you remember that talk.
It's something I'll never forget. Yeah, I still remember going to that talk by Kip Thorne at Stellenbosch University that John Haynes told us about, because he's a fellow, whatever, honorary fellow or something, that he gave a talk there. And I went and attended that. That was in November, I can't remember which year. And I still, we sat with a whole room full, auditorium full of these students doing postgraduate, doctorate studies and so on. And when it came to question time, nobody wanted to. I arrived late, and so I had to sit in the second row. There was nowhere else left. So I was close to the front. So I just put my hand up and he said yes. And I asked him, can you measure gravitational waves by changes in measurements of time by atomic clock? And he said, well, I hadn't thought about it. And then he spoke about the possible science behind it. He spoke about it for 15 minutes, answering my question. And in the end, he said, yes, you can. So I'm not sure, Pierre, but I can't remember his exact logic in that process. But possibly an atomic clock can measure a gravitational wave. I don't know. Maybe we should ask that question of somebody again.
I think I agree that atomic clocks can be influenced by gravity, changes in gravity, but gravitational waves' energy is so low to have an influence on an atomic clock. I have my doubts.
It would have to be a pretty strong one, I think, but I'd like to. I don't know where I can Google that and try and find out and see what the actual effects could be. I mean, those LIGO, those things are so sensitive. I mean, those things are kilometers long, and they measure a movement in mirrors of sort of fraction of an atom sort of thing. So I can imagine that it might not be sensitive enough, even though you're talking about changes of only billionths of a second. So yeah, I just remember him saying that yes, it is possible. It was the conclusion he came to. Well, I don't know if he said maybe it's possible or it is possible. I can't remember. Okay, a couple of people have put on message that they have to leave now. All right, how are you guys going for time? So, Pierre, did you say that you thought we should actually look at the arrow of time section now, or should we leave it for next time? Getting on a bit late now.
I think with people leaving now, maybe we should leave it the next time, but we'll start off on a very interesting topic.
That is probably one of the most interesting sections of that whole talk, I think. I agree.
A question from Joster, whether there could be a younger version of himself. That would imply that you must move faster than the speed of light. So I think the answer to that is no.
Oh, did you see a question in the chat? Sorry, Pierre. Oh yes,
you did.
Yeah, I see it. Oh yes, okay. Thank you so much. Would one be able to find time, fold time, going with a younger edition? Yeah. So that would be a good one for pity we didn't answer that while he was here. Or is he here? Mr. Joost,
Hello, I'm still here. Yes, I'm still here. I think it was just that because you said time is linear and it exists in your memory. So the question is, if you could fold time, would you then find that you can coexist at the same time with a younger version of yourself? And I think that is where it has to be linear. Otherwise, you will find that there are multiple versions of you.
Yeah.
And the other question was,
Yes, carry on.
So and the other one was, if we look at E equals mc squared, c is obviously the speed of light, and so for it to be established, it needed time. So if time is not going to be constant, that equation might somehow be affected and the validity thereof.
Yeah, first thing, remember that equation is a simplified version of the full equation. I can't remember what the full equation is, but you have to take general relativity into account in it as well. That is an equation for I think for a static something, for the energy in something static. It's not if things are moving, then it changes, and it does take time. Relativity is taken into account in the fuller version of that equation. I'd have to find that and send it to you, but yeah, it is catered for. So yeah, and the first part, yeah, time simply, as far as I'm concerned, is not reversible in any way. It's physically impossible. Possibly if you could travel, and remember the speed limit that the speed of light has it's not a limit of light speed. It's a limit of the universe, actually. It's just a factor in the universe which causes that. It's just something that has been measured to be that. There is nobody's worked out why it should be at that actual level. It's just what it is observed to be, and it is a limit of the universe. So yeah, time possibly you could reverse time if you were to be able to go faster than the speed of light. And what you're doing is you arrive at a place before the light that was shining out from your older part gets back to you. So you're still seeing the light from the younger part because you travel faster than light. But I don't know if you're really there even. I don't know if you've done anything with time like that. Even if you could travel faster than the speed of light, but you can't. You can't even travel near the speed of light. And we won't be able to for a long time. We've got a massive machine under the ground in Switzerland to accelerate tiny little particles like protons to near the speed of light with an enormous amount of energy and enough electricity to run South Africa for 10 years, used up in about a week to do that. So I mean, it's just no way. Sorry, I've been rambling on. Any other comments before we go?
The comment about the speed of light being constant actually requires time, the concepts of time and distance to exist, to define it as a universal constant. That's a very, I think, thought-provoking comment. Thank you.
Yes, it was a good comment, but there is a fuller explanation which I'll find somewhere. I have seen it. Okay, I think that guy from I'll think of his name. Just he's done a lot of short YouTube videos on general relativity and all kinds of things. The guy from that Chicago, what is that Chicago facility, Pierre, where they did the muon experiment and so on? Lawrence something, I can't remember.
Lawrence Livermore.
Livermore, yeah.
Livermore.
So there's a guy that's one of the top guys there that's done a lot of stuff over YouTube. Very interesting. Sorted me out on a lot of the correct things and questions I had about special relativity and general relativity. He gives you the proper, full answer on everything, and not and easy to understand terms as well.
He did a very good thing on gravity, and in the demonstration, he had two cell phones, probably cell phones anyway, but he could show the difference in time or the difference in strength, where one cell phone was up on the ceiling and the other one was down there, but in line to gravity. And I thought, to have the ability for that sensitivity, I find it amazing.
Mm. All right. Anybody else?
Yeah.
Anybody hungry and need to go? All right.
Yes, thanks for an interesting talk, and look forward to the next time when we start with the arrow of time.
Yeah, great.
Yeah.
Everyone.
All right. See you in a month. Yeah. Thanks, everybody.
Yeah. Thanks.
Right.
Thanks.
Bye-bye.
Bye.
There's a stop recording.